Hello, hello. So, good morning, everyone. Let's see. I think everything should be working. I will share my screen with you now. Oh, it's already sharing. Okay, wonderful. Yeah, welcome, everyone. Happy to have you here and talk a bit about how to accelerate the delivery of software using the spec-driven development approach. So basically working from specification to code in combination with GitHub Copilot. Okay, my name is Florian Asmus. I'm the CTO at Prodyna. Been with the company for more than 18 years now. Been doing software development more or less my whole life, and always in the enterprise context. And this is also why this topic is also so important to me. One thing I had to learn very early on when starting using AI is that AI in software development amplifies everything. It amplifies the good as well as the bad. And I think this is something we always have to keep in mind when using these kind of tools. And we will see what this actually means. And first of all, I want to start quickly with explaining why this whole vibe coding. So everybody is currently vibe coding. So building software by just chatting with the AI, explaining the AI what you want to do, and seeing the magic happen. And why this kind of development does not really work for the enterprise context. So first of all, we have this problem of the context horizon. So the LLM by default has no understanding of your organization, of your rules, your security, your governance, all of that. It doesn't know that. It has general knowledge. And when it generates code, it does so in complete isolation. But everyone developing software in the enterprise knows it's not about the piece of code I'm really developing. It's about all the dependencies to get this software integrated into the enterprise. And when you vibe code, this whole context is more or less lost. The AI only sees what you immediately present to it, your prompt, maybe a bit of code in the IDE, but that's more or less it. So it can't respect all of these boundaries and these requirements you actually have. And it will produce syntactically correct software, but it does so in complete isolation. And this leads us to the next issue with this, that you have this illusion of competence, and this leads to accumulating technical debt in an accelerated way. So the AI will start optimizing locally and will try to make your software work on your machine in the current context, because it doesn't know anything else. So what it does, if you just give it very vague requirements, what you want to do, like build me microservices that manages users, the AI will do that, and it will start taking assumption after assumption after assumption because it lacks information. So it won't stop. It will just keep on working, and if it doesn't know something, it will just invent something. Here we go. We are at hallucinations, and just taking assumptions in software development will probably not lead to your desired result. Moreover, it will just develop in a random way. It will what I often see is that it includes multiple libraries that more or less do the same thing, and it will use it just because it doesn't really know that it already has something that can do the same thing. And what you get is really messy code. It will probably work because the AI will iterate as long as it takes to get it up and running, but it's nothing that you want to maintain over a longer period of time. And what you're actually building is not a legacy. You are building legacy code, but 10 times faster as before. The AI is perfect in spitting out code, but it really matters the quality here. So when you vibe code, you are building something for right now. You want to see something. You want to experience something. For prototyping, this is massive. This is such a cool thing to experience. But in the enterprise, you engineer your software for a longer period of time, so you can maintain it. You can keep it changeable, adaptable to your business needs. And this is a contradiction here. And trying to prompt things like GDPR compliance or IT security into your software requires a lot of work and a lot of context, a lot of information that you and guardrails that you need to give the AI so it can actually build this into the software. And doing that while vibe coding, while going from prompt to code directly is near to impossible, because then you would have huge prompts, and nobody wants to write them. And what you get is software that nobody understands and nobody really can maintain. So the main problem we are facing here is speed of generation. So we are generating code like never before, versus the integrity of the software architecture. So we have a machine that probabilistically generates code, and to actually guide this to a usable result, we need deterministic specification. So we really need very, very precise, unambiguous specification of what we actually want. And this is exactly what I want to talk to you about today in more detail. And the approach that becomes more and more viable because of technological advances is the spec-driven development approach. So the idea is not to in the traditional software development, we write a specification, we have some document with some diagrams and all the information we need. The developer takes that and starts writing code. And as soon as the developer starts writing code, the code becomes reality and becomes the truth and the single source of truth. It's really, really hard to keep the initial specification in sync with the code that you develop. And what we see in a lot of larger software development projects, there is hardly any specification for what actually happens in the code. And it's, look at the code. The code is the truth. And with spec-driven development, we are trying to change this and bridge the gap from specification to code. And this is really, what we're trying to do is to have a specification that has all the necessary information and context in it for the LLM or for the AI to actually generate the entire code from that. And if we want to do a change to our application, we change the specification and let the AI implement this change. And one approach here is the so-called Spec-Kit. It's an open source project developed by Microsoft GitHub colleagues, and it's not a real tool. It's a workflow engine for AI. So it's a workflow that you can use to guide the AI in the development process. Yeah? And how does that look like? We're starting with the idea, a concept, or something that we want to achieve, our intent, our business intent. So what are we trying to do here? And we are feeding this into the specification phase. And in the specification phase, we are not jumping from we have an idea to code, but we're putting this into a structured specification. And the AI will work with us and iterate with us to refine this specification and check it for plausibility. The AI will help us in writing this plain English specification. And once we have fully specified what we want to do, we will tell the AI to, hey, generate an execution plan. How would you implement this specification, these business requirements? And the AI will start evaluating technologies. It will take all the input from the specification and figure out how this can be actually implemented and break it down into a task list. And then we have the final step that is then fully automated through the AI, taking this plan, taking this execution plan, and actually implementing it. And this is the spec-driven development workflow. A bit simplified, but you will see these stages everywhere. And now let's have a look a bit deeper. So there's actually a phase 0 in this whole process, because we need to establish the basic principles of how we develop software. So we're establishing a so-called constitution that contains non-negotiable articles of how we are doing things, and the AI must follow all these rules in there when doing specification, when doing the planning, and when doing the actual implementation. So this constitution is fixed across the entire process, and it gives us a way of telling the AI, or giving it the boundaries it should work in. For example, we can define NFRs, the non-functional requirements that always have to be respected. Or we can define our testing procedure. We can tell it, hey, we want to do test-driven development. That means before you write the actual code, please write test cases, check that all the test cases are failing, and then start implementing against these test cases. So we can tell that to the AI, and it must work along these lines. Simple example of this governance layer is we want to follow a library first principle. We want to test first, to test-driven development. We want to simplify as much as possible. So as soon as the AI detects higher complexity, it should think about, hey, how can I simplify this? Or if it has multiple ways of implementing something, it will choose the simpler or simplified way. And this constitution really provides the foundation and gives the enterprise a way of communicating all its necessary way of working and guidelines into the entire process. And once we have established the constitution, we move into the specification phase. So in Spec-Kit, there is a special command, which is the specify command. And this is the product layer. So here we are talking about describing our business intent. And the AI, we can tell in the constitution, hey, AI, make sure that in the specification, we don't put implementation details in there. We must keep it agnostic and focus on the business intent. And it will guide us towards this. And in the specification process, we're describing what the outcome, what we actually want to do. And Spec-Kit delivers a template of how such a specification looks like. And the AI will go through this template and we'll start asking questions, and we can iterate with the AI to refine our specification. But it's clear text, it's English text. We can always go in and enhance and modify our specification manually if we want to. But the AI will speed up the initial setup massively. So we have a clean encapsulation of our business intent. With that information, we can move on to the next and use the plan command in Spec-Kit to take the specification MD, markdown file, text file, and actually figure out how to implement that. And all these commands, like the constitution command, the specify command, the plan command, these are very elaborate prompts. We will have a look at them in a second. That also rely on each other. So, for example, the specify command will include, the prompt will include, hey, everything you do, please look at the constitution first and make sure everything is aligned to the constitution. So all these very elaborate prompts are intertwined, and they rely on each other and reference each other. So in the plan phase, what will happen is the AI will break down the technical tasks that need to be done, and it will even create like a research document. Hey, we have these requirements, these non-functional requirements. Let's see, these technologies would match. That's why we would use them. And you can always go into the discussion and say, hey, but we have a standard here. If you even have a standard technology stack, you could put these things in the constitution and tell it, hey, this is what we support in the company. Please use these when you get to the implementation. You can do these kinds of things. And then it will also start designing contracts and data model. So based on the requirements, it will start defining interfaces, OpenAPI, for example, or GraphQL, and it will design the data model. So what we get at the end is a very detailed plan of how to implement the initial specification. And once that's done and refined, and we're happy with that, we can tell the AI, hey, now implement this. And this is where actually the coding happens. So the AI will go in, scan will scan the full execution plan or the implementation plan, and will start iterating bit by bit. And it will respect the constitution. So for example, it will first start to create test cases for the first implementation step, and it will really, you can follow the internal conversation and see how the AI works, how Copilot works through the issues, identifies problems, goes back, and there is really a conversation happening, and it feels like you can watch a developer doing its work, but probably much faster than any developer can work. And you can always jump in and guide the AI during the implementation process. But it actually it starts working like a normal developer would do. And hopefully at the end of the day, you get a running application out of this. So a little bit on the clock. How does this actually work? I will now show you my Visual Studio Code. And here we go. So you should see my Visual Studio Code now. And I checked out the Spec-Kit project. And you can have a look at it. I have a link in the slides later on, but just search for Spec-Kit and you will find it on GitHub. And this has all the templates and everything you need. But how it actually works is that you just run a simple command and specify init and then your project name. And what will happen is it will ask you what kind of AI coding assistant you're using. So it supports a lot of these now, but the thing is that what Spec-Kit actually is a collection of elaborate prompts, and depending on the coding agent, they are expected in different folders, in different formats, and so on. So this is actually the only thing that this does. I'm using GitHub Copilot, so let's do that. There are also some scripts included that the AI can run to generate some overviews. And in my case, I'm on my Mac, so I will use SH for that. And that's it. Code demo. Sorry, don't save. Here we go. So as you can see, what Spec-Kit actually did is it bootstrapped a couple of files. And we can walk through that. You can already see it nicely integrated into the Copilot GitHub Copilot UI. And first, we have the Specify folder. What you can see in here is mainly the templates I was already talking about. So that's, for example, the template for the specification. You have a look. It's a lot of placeholders. So this is the general structure, how a specification file should look like and what it should include. So this is number one. Spec-Kit will give you these template files. Then it has a couple of scripts, but we don't have to go into that detail here. And the second big part is, that's why I had to select the AI assistant. It now generated a .github folder with the prompts. And these are the elaborate prompts I was talking about. For example, the specify prompt. Nothing in there. They just changed that. They are moving currently the commands to actual custom agents. It's a new feature introduced by GitHub Copilot. You can see that even here. So these are like custom prompts. And now down here, you have Spec-Kit as custom agents, basically. So that's this native integration into the different AI assistants. If you're using Claude Code, for example, the structure looks a bit different. But this will just translate these elaborate prompts into the specific coding agent format. And when you have a look, for example, into the specify agent MD file that Spec-Kit delivers, here you can actually see the prompt. So that's the prompt executed by the AI. So you can see it's quite elaborate and it's developing. And what you also can see is a bit of metadata for the custom agent, including handoffs. This is also a very new feature. GitHub Copilot allows you to basically tell the agent what would be the next step. I can hand over to another agent, for example. Yeah, and this will guide you also in the UI, in the chat UI, what your next steps are. Yeah? So let's quickly give it a try, and I have prepared a little prompt here. First, we need to set up the constitution. Yeah? We could use the Spec-Kit constitution command, or just switch to the constitution agent and tell it, hey, create principles focused on code quality, testing standards, user experience consistency, and performance. Include governance for how these principles should guide technical decisions and implementation choices. There we go. And what will happen is it will execute this custom agent constitution. And you can see, hey, you're updating the constitution. This file is here. And it's a template, and this is what you need to do to actually build up the constitution. Yeah? And now it's working, and we will see it will start reading. Hey, I'm reading my current constitution template. We already know it's under memory constitution MD. And it will start exploring the project and updating eventually the constitution. Now let me create an updated constitution. So it's a way to easily get started. Usually this is something that you commit on in a project and develop bit by bit, or even company-wide. So this is something you can share across your entire company. So let's see what happens. Luckily, I already did that. Let me jump over here. I already started a full implementation to not wait for the AI. And here you can see an implementation result. So in the constitution, we now have things like, okay, it starts up here. Maintainability. You must be self-documenting with clean naming conventions. You must, so there are a lot of requirements in here. Testing excellence, for example. You must be written and reviewed before implementation. So you must write the tests first, test-driven development. And you will actually see the AI working in the exactly in this way, because this really constrains the AI. It guides it in its process. Yeah. Okay. Here we go. So you can see it now established a first constitution. We should review it. We should work on it, and it will even tell you, hey, let's commit it. Yeah. Please commit. And now you can see how this works. It actually runs the commands in your command line. It will figure out, okay, commit was successful. We have our first version committed. And you can see no changes. Nice commit message. We have the project constitution. So agent mode really allows you or provides the AI access to more or less the entire IDE. It can execute commands, read the results, change files, everything. Yeah? So it can really, you can watch the AI working in the IDE. Yeah? Okay, so this is the workflow. Now we have our constitution. In the next step, I want to build a little application. So the next step you can see here, we have the handover to let's build a specification. Gives us it switches to the specify agent, and I can I have a prepared command here. Hey, implement the feature specification based on the updated constitution. I want to develop Taskify, basically a task manager with Kanban style boards. Yeah, it's the standard example from Specify. So have a look, and now it actually starts creating a branch. So it's Git aware. That's also some nice thing. It understands Git. It will create a branch for you based on the specification. Yep, I want to allow this. There's a little, now it's actually running the script for creating a new feature. Hopefully that works. Mm-hmm. Does something. Let's see what happens. But I can let's take the time and have a look at a finished implementation. So what it will do, it will create a branch for you based on the specification you put in, and will create the specs folder. In the specs folder, the first file it creates is the spec.md, and we can have a preview here. So it takes the specification template that was delivered with the init command from Spec-Kit. So we have the template, spec template, and this one was used to create the specification. Yeah. So drag and drop library, local wrapped. I told it to be agnostic and allow for the MVP browser only, and later connect to a backend. Right. Clarification question. So here we have the user stories and testing scenarios. So our business intent: user select and selection and project access. Oops, sorry. And it really describes in very detail what the user story looks like, why this is a priority, how you can test it, what the acceptance criteria are. And then you have the Kanban board, task status management, and it really went down and started to write all this from my specification. There are a lot of assumptions initially in here, because I only prompted like 20 lines, yeah, but it's a starting point, and you should go in and do your normal specification process that you do. Yeah, so have a requirements engineer review that, rework it, and refine your specification as much as possible. Here we go. So it's now creating my spec MD, and probably it's now reading the template and replacing the template sections with the actual content. So this is the first step, and then the next step, when we are happy with our specification, we can tell it to do the plan. And there you can see we have the plan MD already generated. It relies on the specification. Hey, that's the summary, that's the technical context. We have a constitution check, so please make sure everything is aligned with the constitution. And it will update these documents as well. So at the beginning, they are not checked, and bit by bit, it will will verify and mark the stuff as implemented. Then we have the entire project structure planned out, and there's also a research. So we have the research document. Technical contexts have been resolved through dependencies and pattern research. No technical blockers identified. And then, okay, the decision is we're using this technology. That's the rationale. We have some other alternative considerations. And it also starts generating this quick start guide on how to actually use this project, how it's structured, how a developer can get started developing in this project. And with all this information, so there's even like technology-specific architecture documentation. You can adapt that to your requirements and your organizational standards. And once you're done, another thing, it designs the data model. So it will, all of this is, I did that yesterday, just running through the process, letting the AI go wild. But what you can see, it really starts modeling down your data model. As always, you can always go in, and you should always go in and work on these documents like you would in a regular software development project, because the specification is where the actual work is done. And if you find things in the code that are like bugs or features that have been misinterpreted, what you need to do is go back to the specification, make it more clear, and fix the issue in the specification, and then tell the AI, okay, now I've updated the specification, go and adjust the implementation. And that's really the process where you maintain your specification, refine it, enhance it, adapt it to your business needs, and the implementation at the end of the day is fully generated by the AI. So there is no manually writing code here anymore. At least that's the long-term goal. The AI should be able to implement end-to-end based on your specification. And if you like to use a different technology because of constraints or whatever, Google decided to not support the project anymore, you can do that because you have the specification and in clear text, and you can tell the AI, hey, I want to switch to a new technology. Please re-implement. Maybe my non-functional requirements have changed. Hey, that's why we need to do something different. The AI will implement it for you. Okay, so this is the process, and it looks like when you start using that, you really, this conversation has been quite extensive here. So you can really see it runs tests, it evaluates the output that's happening in the test cases. and iterates through this process, fixing bugs, identifying problems, reworking things, simplifying things, and marking the tasks that we have defined as completed once the tests really pass. Yeah? So this is the entire process end to end. Let me switch back to the slides because we don't have that much time anymore. So this is Spec-Kit in a quick run through. Okay, it's still early stage. It's developing like crazy and changing like crazy, as everything in this field. But the general approach is well researched. So there's a lot of research in the past, but now we're at the point where technology really allows us to implement such an approach. Yeah. We were always thinking about, hey, how can we make our specification translate into code directly? Everyone probably did some model-driven development where you modeled your software and had code generators generating the code. That was a struggle. But why does it work now? And it's a combination of multiple aspects. So number one, the most important one is AI got to a point where it really can reliably generate working code from natural language specification. So the models get better and better and better, but I think we got this point where with a very clear scope, AI can produce really good code. And another aspect is that modern systems have become too complex to manually align implementation with specification all the time. It doesn't work anymore. We don't have the time anymore because pace is picking up. So the rapid iterations that we're doing, like developing in very short iterations, pushing out continuous delivery, is demanded by our business because requirements change all the time, and we have to keep up. And at the moment, we are optimized around code, making coding more efficient, making automating the code delivery process as much as possible, but not looking at the specification. The specification is more or less left behind. And with this approach now, we are bringing back the importance of specification and making it changeable and adaptable, more or less like code, as quickly as code. So this is really where all these three aspects converge, and why I think that for enterprise software development, this will be the way of how we will work. And this also highlights the importance or the tasks that developers will be doing. They will guide the whole process. They will influence and review the specification, clarify the specification, and really focus on the creative part of software development, and not on the manual putting stuff into code part. This will be done by the AI, but there's still tons of work to do. And when working in this way, you really need to have the ability to understand the business requirements, to guide the AI, and steer it towards the goal. And that will be the work of a software engineer in the future. And a final thought. So what would you build if your ideas could directly become code. So now everyone can start building. And with that, I want to close, and let's have a look at the chat here, or the Q&A. I think do we have any questions or chat messages? Now Spec-Kit can, we have one question from Alian. I'm interested in how Spec-Kit can be integrated or interact with GitHub issues. Haha, good one. In a sense that functional customers with access to the board can validate, approve, make corrections to the functional requirements. Yeah, that's a very good question. And that's a question that's not only for the integrating into boards, but integrating it into the rest of the organization. Basically, also, how can I integrate, for example, my design work into this process? And maybe I can quickly show you something. Or how do I share the constitution? At the moment, it's a very mono-repo, everything in one place approach to get a feeling for the workflow. That's why we are still in this mono-repo approach, and to make it accessible for everyone. But in the future, I fully agree, parts of the context will move to systems where they actually belong, or where external, like business people can access and interact with them without going into markdown files. Yeah, and what I already saw in the Spec-Kit code is task to issue. There is already like an agent that uses the GitHub MCP server, so the AI interface for GitHub to create issues. And this is just included or encoded into the prompts, basically. So this will hopefully be the way of integrating this. And we are currently working on, for example, the Figma integration. We have designers doing all the screen designs and everything. And the idea is to also tell the specification prompt, hey, please include the Figma designs into the specification and make it accessible for the implementation step. Okay, so I hope this helped and gave you a good overview of what's happening here. And I hope you enjoyed. And if you like, feel free to also contact me. I think I have my LinkedIn profile is on my intro slide, or follow Prodiner on the different social media channels. So here we go. Thank you very much. Or do we have any more questions? Yeah, recording. Yeah. Thanks, Nina. Cool. Then I will close the session. Bye.